Atom economy.
It's like baking a cake.
Think of it as a measure of the amount of starting materials that end up as useful products.
Regardless of how carefully you mix and transfer the ingredients, there will be wasted atoms, for example, the eggshells.
The atom economy is therefore not 100% due to this waste product. For some processes, the waste products can be hazardous and expensive to dispose of too.
You need to be able to calculate atom economy and suggest which route is best for making a particular product when also considering other factors, such as rate and yield.
Let's look at a real Level 5 GCSE exam question for calculating atom economy.
The useful product in this question is nickel, and the atoms in the carbon monoxide are therefore wasted.
To calculate the atom economy, we need to compare the relative atomic mass of just the useful nickel with the total of all the atoms present. These are shown in the balanced equation.
In a chemical reaction, atoms are not created or destroyed. They just rearrange. It therefore does not matter whether we use the total mass of the atoms of the reactants or the products in our calculation, as they are the same.
As this question gives the relative formula mass of nickel oxide, I am going to use the total mass of the atoms in the reactants to compare with nickel, but it would actually make no difference if I used the total mass of the products, as previously stated.
It is a useful strategy to write the information given in the question around the balanced equation in chemistry calculations to help organize your thinking.
We are now ready to calculate the percentage atom economy of producing nickel by this route. The relative atomic mass of nickel is divided by the total relative formula mass of the reactants, then multiplied by 100 to give the percentage atom economy.
Always remember to look back at the question to ensure that you have given your answer in the correct format. In this case, to 3 significant figures.
Here is a more challenging Level 9 GCSE question, which does not just require a calculation of percentage atom economy, but some more advanced problem solving.
We need to calculate the relative atomic mass of an unknown metal, X, given its percentage atom economy and the balanced symbol equation. I am going to give you a few seconds of thinking time to consider how you would solve this problem. Please remember to use my earlier advice about writing the information in the question around the balanced equation to help organize your thinking.
So, we want to find the relative atomic mass of X, and there are 3 waters formed with a total relative formula mass of 3 times 18, which equals 54. We are also told that the percentage atom economy of X is 77.3%.
If we can work out what relative atomic mass is produced by 1%, then we can work out what 77.3% equals, and hence the relative atomic mass of X. This can be achieved by using the information given about the water.
An easy first step is to find the percentage atom economy of the water. This is simply found by deducting the percentage atom economy of X from 100 as the rest is water. This means that the percentage atom economy of water by this route is 100 minus 77.3, which equals 22.7%.
We can now find out what relative atomic mass 1% is worth by dividing 54 by 22.7. 1% therefore equals a relative atomic mass of 2.38.
We can now find out what 77.3% is, and hence the relative atomic mass of X. With my full previous answer still in the calculator, as we only round at the end, 2.38 times 77.3 equals 183.9. This is our final answer for the relative atomic mass of X, which rounds to 184.
So, what else could we be asked about atom economy?
Other than calculations, this is another style of question about atom economy. So, why are reactions with a high atom economy used in industry?
Well, We want as many atoms as possible in our reactants to end up in a useful product to maximize profit, and to reduce the amount of waste products to dispose of.
What else could you be asked? Think about how atom economy could be improved. If we can find a use for the other products, then the atom economy becomes 100%.
Anything else?
Trying to preempt what an examiner may be able to ask is a good way of testing your understanding and rehearsing for the exam. I think that if there are various ways of making a product, then it is not just atom economy that we have to consider, or just the disposal of waste products, but also how fast the reaction is. There is no point having a higher atom economy if the reaction takes much longer. These are real-life considerations. So, here are just some of the considerations. We will learn about percentage yield and equilibria in other videos.
For now, thank you for listening, and I hope that you have found our lesson content and strategies useful. You can help us by hitting the subscribe button to help grow our channel so that we can produce further free GCSE resources.